Good morning, dear participants. I warmly welcome you to day 7 of the iTech program, which is hosted by Indian Institute of Technology, Delhi, on the theme of energy system and carbon neutral economy. We will be starting the first session of the day, which will be taken by Professor Priyanka Kaushal. The topic for this session is climate change, energy and resilient ecosystem. I hand over the rest of the time to you, ma'am.
Thank you, Emily. Thank you very much. And let me share my screen. So I assume my screen is visible to everyone.
It's visible.
Yes, thank you. So yes, I'll be a little change in the topic, but at the very core, it carries the same message. We'll be looking at the ecological impact in context of energy use and climate change. And the topic that we intend to cover today is ecosystem, ecology. We will see a case of coal mining. We will do a hands-on, very brief hands-on exercise of it. So if you have a pen and piece of paper ready with you, please keep it handy. And then we will see what do we understand by valuation of ecosystem services, the various services that we derive from our ecosystem. I'm sorry, I'm a little under the weather at the moment. So we will see how do we evaluate it? How do we put a monetary value to it? Very complex procedures to be followed. But many of you probably are with an economics background and would have studied it. But those who have not, it is important that we put value to our services that we are drawing. So if a river flowing by your neighborhood, then what kind of services it is providing? And the best way to estimate is to look at it if the river is not there. Normally, we take things for granted. Like, there's a river flowing by, it's a natural service available to us. Why should we add a value to it? But because of that river which is flowing by our neighborhood, we get water supply. We do so many services. It also, in many places, the irrigation is supported by that river. So there is an impact of that river on every aspect of our life, and we start adding value to it, right? And then, and in monetary terms, the valuation, of course, these services are priceless. But if we try to put a monetary value to it, then what are the various methodologies by which we do it? That is important, and especially important if you are planning to set up a project. A project could be, since we are talking in terms of energy services, energy perspective, let's say I plan to set up a hydropower plant in a certain ecosystem. So when this hydropower system will start operating, and the major thing that we construct for hydropower services is the dam. So if the dam come into existence, how it is going to impact the ecosystem? What is the value which I am going to lose or which is at stake? All these things need to be considered before we set up a hydropower plant. Similarly, when we go for a coal-based power plant system, let's say, then power plant is one thing, because normally power plant and the mining parts are separated, but because of the power plant, some mining has to be done, right? So let's say it's the very first power plant that we are setting up. Then there is a mining thing. Because of that mining, what kind of damages we are bringing to the ecology, which also means that the services that we are deriving from the ecology. So let's say there is a forest. It cleans the air. So if I chop down the forest just to clean the top surface so that I could mine, then what kind of services that are impacted that may become zero? So what is the value to it? That is important to understand, especially for big projects like mining, setting up a power plant, setting up a hydropower projects, so on and so forth, right? So all those things, putting a value to it is very important so that we could frame our policies accordingly. Many of you are in government sector, primarily looking after the policy part of it. Therefore, valuation of all these services that we are deriving from nature, right? We know they are very precious, but how precious are they? They are like they are very precious. You can't put a value to it, but let's try to put a value to it. Because when we add, when you add value in terms of monetary value, that the cost of this is this much $1 million, right? The impact, we take it differently because we all tend to think in a certain terms. So you understand that if that thing, if that forest, if that river is not there, of course, in many places life would not survive. But since we start taking things for granted, it is important, to nudge us and bring us to kind of in our senses that, these are the values, this is the monetary loss that I may occur, or people who are deriving their livelihood from that service may suffer. So it is important that we add value to it. But let's start understanding ecology and through some cases, what kind of changes it can bring to our life, what kind of an impact it may bring. So if you look at an ecosystem, there is an ecosystem everywhere. So what is it, ecosystem? The scientific definition for it is an ecosystem, as you can see, includes all living things in a particular area. All living things, that basically means the plants, the animals, the organisms, the microorganism, and people, of course, we. Interacting with each other and with the element of the non-living environment, right? They all interact with each other. There is an impact that is there. Some of them we notice, some of them are so intuitive and so much a part of our life that we did not notice it upfront, right? So their interaction and their interaction with the non-living environment, like the weather, earth, sun, soil, climate, atmosphere, so on and so forth. That is an ecosystem. It involves everything around a boundary that you put, and that boundary is the particular area. So in scientific term, we say, what we are studying, we call it as system, and what is outside that, we call it as surrounding. But when it comes to ecology, ecology is sitting right at the cusp of system and surrounding. What it does, it studies the relationship between the system and the surrounding. So here the system is your plant, animal, organisms, everything is covered, including people, and your surrounding is a non-living environment as per this definition. So weather, earth, sun, soil, climate, and atmosphere. So if I'm studying a neighborhood, your neighborhood, right? Whatever area you live in, what is the last name, such and such community, right? And I put a boundary across it. Then I see that what is the interaction happening within the community, inside the boundary, like you, your neighbor, the animals that are there, the microbes that are there, and how you and all the living organisms in together interact with sun. What is the role of the sunlight that you receive? What is the role of the soil which is there? What kind of an atmosphere is available to you? What kind of an air you are breathing? What is the impact of that air on your health? So that is the interaction. So that is the interaction between, just a second. Yeah, so that is the kind of interaction that is happening within the system and the surrounding. An ecosystem becomes very complex because it is a dynamic process. There is a constant interaction happening between the system and the surrounding. And ecology is to study the relationship between the system and the surrounding. And as you can see, it is very dynamic in nature. There are plants, microbes, all these communities, they interact with each other. And all of this is an ecosystem. A small pothole that you see on the street, on the roads, that is an ecosystem in itself. The water, if it's a rainy season and water is stuck there, it holds water in that pothole. This is an ecosystem as well. Various kinds of microbes will grow in here. They will have different kind of impact over you, over the surrounding. And something as big as the ocean basin, even they have an ecosystem of their own, right? And they have an interaction happening. Since it is bigger in size, it's easy for all of us to comprehend the kind of life it supports, the kind of aquatic life is there, the coral and so on and so forth, right? So this is also an ecosystem. This is also an ecosystem. As you can see here in this one, the boundary is the pothole. And here, this is the boundary, right? The boundary here is the entire ocean. basin, and what kind of an interaction it is doing with its atmosphere, with its other kind of a surrounding which is available to it. So the relationship between the living body with its surrounding is the branch of science that studies that is called the ecology. And everything is a part of it, right? The atmosphere is a part of it, the biosphere is a part of it, the lithosphere is a part of it, everything is a part of it, because there is a relationship there. And it's not easy to study, it's very complex, because this is it's a dynamic process. It changes. There's exchange which is happening continuously between you and your atmosphere. You are breathing, for example, right? So there is a change which is happening. There is an interaction that is happening constantly. So that has to be captured. And as you can see, the size, depending upon where you are putting the boundary, the size varies, but all of them have their own impact. So you can see here, this is a kind of an ecosystem where we have trees, we have birds, owl, wolf, there's an aquatic body, there's a fish, there is a rat, there is a frog. All of them are there, and they are interacting with each other. They're in continuous interaction with each other. Right? The food cycle that we study, there's an interaction happening. One organism eats the other organism, and how the leftover decomposes, it goes into the soil, it adds nutrient to the soil, and a part of it is decomposed and it goes back to the atmosphere. So study of all that is a part of ecology as well. So you can look at it. An ecosystem can be looked at in terms of functions and processes. There are various processes which are happening, the breathing that is happening, the swimming that is happening, the decomposition that is happening, and somebody eating one of them. How there is something which is transferring from one unit to the other unit. So food web is one such thing. Water flows is other. The rain which is happening, it goes into the river, some of them percolate down, fills the lake, how they interact with each other. And then other is the nutrient cycle. Now these three is something we have been studying since our high school, but all of this represents a kind of ecosystem. And what is it in that ecosystem? What is it that you are interested in? All of them together could be a part of the ecosystem. Now, there's a broader cycle. Nutrient cycle, water cycle, and food cycle could be a subsection of it. As a nutritionist, maybe I'm interested more to study about the nutrition cycle, and I for my study, ignore the water cycle and the food web. Other may consider all of them, but in nature, all three of them are in constant dynamic equilibrium, right? They are in dynamic equilibrium with each other. Now, let me show you, just to set the stage, a video on coal mining.
To me, as somebody who had grown up in the mountains and loved the mountains, the idea that a coal company had the right to blow up an entire mountain and wipe it off the map forever was just unconscionable. These places are not just sort of physically important to people, but they're spiritually important to people, and once they're gone forever. You can't put a mountain back together, and I just deeply feel that no company has the right to take away something that ultimately belongs and matters to so many people. Just look across the valley next door. That's what it used to be like, you know, one of the most diverse forests on the planet, and now it's a wasteland. Over there used to be a valley and a stream that's now covered up with thousands of feet of boulders. That's never going to be the same again, and it's over 2,000 miles of streams have been buried in Appalachia, some of the most diverse streams on the planet, some of the cleanest water on the planet, and that is a huge loss to this part of the world.
When that rock material is pushed over the edge of the now flattened mountain, It ends up dissolving a lot of minerals into the water, things like iron, magnesium, calcium, and organisms can't tolerate that. So it kills organisms in the stream. And so that material, that water that is now heavily polluted, runs out of the base of the valley fill into streams and eventually into rivers below.
They also store the mining waste in these huge earthen dams, and they're holding back billions of gallons of toxic sludge that's leaking into the drinking water.
Everybody's wells pretty much is contaminated in one form or another. So I don't use the water to cook. I use it to do the dishes, but that's about it because you can wipe the water off. There's a guy that we tend to help out every now and again. He is blind from the water. He could take his water, turn his water on, put it in a clear water bottle, put his hand over it, sit it for a few seconds, even put a cap on it, take the cap off, and take a lighter and light it, and water will burn. So, yeah, water around here's pretty bad.
So that was very briefly on how a simple mining activity, which was done on a mountain top, on a mountain range, the various kind of impact it has. Of course, there is a biodiversity loss. The wastewater which is generated was stored. I mean, a huge amount of water that comes out and that is used in the processing part of it is stored in an earthen dam. Like you create a dam for it and you store the water there. The water seeps, the groundwater pollutes, and you see what kind of an impact it has. Not just the groundwater, it seeps. And as you understand, water has a tendency to flow toward lower, from high pressure to low pressure areas, from high pressure zone to low pressure zone. And because of the slope, they flow down, and they also pollute the river, the downstream river. And I don't know how far the river is flowing and who all are impacted because of that. So when you try to measure all that, all the impacts that is happening, that is the valuation of it, right? That is the valuation of how many people are affected along the path of the river before it ultimately merges with the ocean. So all that valuation of it is what is considered as the valuation of ecosystem services. And when you try to temper with it, when you try to disturb that dynamic equilibrium that it has created with the nature, because of these kind of major projects that we intend to bring in, right? So as you saw, if the mining is done, of course, the idea is to take the coal to a power plant. Of course, if it is done, or if it's an ore mineral, take it to the processing unit, if it's for alumina, or if it is for aluminium, or if it is for iron, whatever it is, right? And the mining we are doing mining. And whenever we talk of mining, it's a big change in terms of land use. The land otherwise was providing so much of services, ecosystem services, in terms of purifying the air. That we all can comprehend. That's what plants do. With cleaning up the air. So they take in all the CO2. They are the best form of CO2 storage. You heard about all the CO2 storage yesterday when Rahul was speaking. And the last thing that he talked about, the CO2 storage, were plants. They are the best form of CO2 storage. Like they not just store CO2, they return oxygen back to us. Nothing could be as good as planting the trees. And they are the best form of CO2 capture and storage, right? So he talked about it very briefly. So all these services, these plants, these forests, these mountains are giving it to us. So when we destroy them for some economic benefit like mining, and also we need to put a value to it. How much amount of coal I'll be getting? I understand that there are certain spiritual, there are other kinds of attachment people have with their thing, but even if I just park it for a moment and only focus on economic part of it, just the financial part of it, how much benefit I'll be deriving in terms of if I'm an industrialist or an entrepreneur or into coal mining, what is the amount of coal that I'll be extracting from it, vis-a-vis the service that the forest is now providing, I'll be bringing it to a complete zero. And totality, whether I'm in net profit or I'm in net loss. That is what as a conscious business house one need to do. So let's move forward. So we studied a very brief video about coal mining and how it impacts our ecosystem, right? Mining not just impacts the local biodiversity, but it also impacts the downstream communities as well. As you just saw that if there is a river flowing by, what kind of impact it has on the river body. Therefore, it is important to assess the services that we are deriving from the ecosystem. And as you can see here, one methodology, one trial was made to assess the ecosystem services that we are deriving. And the standard model identifying and categorizing the ecosystem services come from the Millennium ecosystem assessment methodology and report. As you can see, there are so many reports that has come up. And MEA was called by the United Nations, it was in 2005, by the then UN Secretary General Kofi Annan in 2000. It was like asked to do something, try to quantify things under his headship in UN when he was a Secretary General there. And then it was published in 2005. So it took some time. As you can see here, it is not just a single report, but it's a rather series of assessment. They have done it for various things. They have come up with a methodology, how it could be done. So if you are interested, the website is given here. You can go and check how they have done. I'm not saying it is the ultimate way of doing it, but it certainly is a very handy tool if you and I want to carry out the first assessment or want to create, create the framework of ecosystem valuation for our local need. So we can start with this document, right? As you can see, the main objective of this MEA, which is the Millennium Ecosystem Assessment, like where we stand today, what kind of degradation we have brought and where we are heading to, was done primarily to assess the consequence of ecosystem change for human well-being. So as you can see here, it is primarily focusing on human and to establish the scientific basis for action needed to enhance the conservation and sustainable use of ecosystems and their contribution to human well-being. As you can see here, this particular one was done keeping human beings in mind. So what kind of an interaction is happening between the ecosystem and the human and our well-being, and what is it that can be done? So this is the website. You can go in there, right? You go to this website. This is how it looks like. All kinds of reports are there. Tables, states, scenarios, policy response, assessments, everything is there, and they keep on updating it. So that's a very handy tool, and I think we all should look at it once before we start evaluating our ecosystem. And as I told you, the whole idea is it becomes very easy when you start with the anti-question of it, that what if it is not there? So if I say, what if the river which is flowing nearby is not there? What if the mountain that you see is not there? So when you say it is there, what kind of a service it is deriving? Maybe a bit, it's not easy for us to comprehend or relate to all the benefits that we are deriving. But let's assume tomorrow you get up and that is not there. So what impact it might bring to your life or to the other organisms? So if you start from that point of view, it becomes a little easy to start. So in the Millennium Ecosystem Assessment Report, as you see here, they primarily divided the ecosystem benefits, that the services that we are deriving, into three major categories. In fact, 4 categories, but 3 major here. That is the provisioning products from ecosystem. What is it that we are getting from our surrounding? Ecosystem basically means from your surrounding. So our surrounding provide us food, fresh water, fuel, wood, fiber. We will go in detail of it. Biochemical and genetic resource. That means the biodiversity which is there. It's not just human being. There are bovines, there are cow, there are buffaloes, zebra, dogs, cats, and microbes, genetic resources, as you can see here, that are available in all sorts of microorganisms that are thriving. So that is genetic resources as well. Regulatory benefit, as you can see here, the climate that we see, the weather that we see is also because of the ecosystem. Right? So the climate regulation, disease regulation, water regulation, and water purification. Even water purification is done by the ecosystem, the flowing water. The more it gets in touch with air or atmosphere or oxygen, as you can say, it purifies itself. Right? So all these services The regulatory services are also derived from our ecosystem. Then there is cultural benefit of the ecosystem. You see mountains, and when you feel a little stressed out, it is often recommended you go on a holiday to some mountain or to beaches and things like that, right? So they also provide spiritual and religious kind of an benefit to us for recreation and ecotourism. So a lot of ecotourism sites are now coming up across the globe. So that is again derived from ecotourism, is all about ecology, about your neighborhood, aesthetic, inspirational, educational, sense of belongingness, and then there is cultural heritage. Many communities, they put them to the highest level of their worship. They worship the nature, the culture, and their neighborhood because they are responsible for their survival. That's how they take it, and that's how they value it, right? And there are many such videos you could get, many such literature you can get, where you could see that how people value such natural services that they're getting. And I'll just very briefly talk to you about one such practice here in India. So if you go to the state of Rajasthan, we have it's a desert kind of an, some part of it is desert, and it is a water stressed location, right? And from the very beginning, it's not that it has happened something very recently. The water level, the water tables are very down, so they treat water as a very precious, extremely precious commodity. So what they do, they have the kind of well they develop, the kind of arrangement that they have to capture the water, because a lot of mechanisms. We all understand that water is a very precious resource, and they have realized it from the very beginning, right? So even in the 12th and the 13th century, they identified in their own community where they are living the contour. So they understand the contour, and as I told you, water always flows from a higher space to a lower space, right? From an elevation to a depression. So they identified the most, the deepest part, or the lowest part in the neighborhood, and they demarcated it, put some stones, and that place was identified as a source where water would be collected. And that place is so revered, so respected, that nobody walks on it. Nobody walks on it, because if you walk, you bring in some kind of contamination with you. So even in dry season, when it is empty, even today, if it is all, the water is all used up, you are waiting for the rainy season to come. But even at that time, you see, because you have demarcated, and this is a practice they have been doing for last hundreds of years, certainly for 800 years. So those stones are kind of taken as a symbol that you can walk past those stone, but you will not trespass in the area which is covered, kind of an controlled boundary for the storage of water. And the women in that community, they go and they worship that place, and the value of, or the status of that piece of land is no less than a god for them. So this is the cultural heritage we have with our ecosystem that we have. And I'm sure every community, all of you have certain similar story to relate to, right? I just gave you the story that comes from my region. And then there are other services. They are a little slow. For example, the soil formation, but the way soil is formed is, again, it is important. It's on the soil only, that it's the nature of the soil that decides what kind of vegetation will grow in that area. So how the soil is formed, the nutrient cycle, right? That again, these are the supporting services that are derived from ecosystem and the primary production. And let's look at them, all of them in detail. So as you can see here, so the Millennium Assessment Report has categorized it into 4 categories: provisioning services, regulatory services, cultural services, and the supporting services. Now let's look at all of them one by one. So provisioning services, basically, as you can see, food, which included seafood, games, crop, wild food and species, raw materials, genetic pool, as I told you, various kinds of genes are there. We pick up gene from one, we induce another for better qualities. Even if you look at how vaccines are made. So genetic resources, very important. Medical resources, including pharmaceutical, chemical model. And if you look at medical resource, for that matter, the pharmaceutical tablets that we take, right, when we fall sick, many of them are derived from these local communities. The kind of plants sorry, they were using, You take that, you study it scientifically, and you identify the component, that chemical, which is responsible for curing you, right? So if you go to older communities, like ancient communities, they were using those plants and resources directly. Now the pharmaceutical companies study the molecules, right? But the origin of that is still plants, or the ecosystem that is around us, right? So medicinal resources, energy, hydropower, biomass fuel is coming from our ecosystem. And ornamental resources as well, as you can see here, handicrafts, jewelry, pets, and souvenirs like fur, feather, ivory, though many of them are now banned, but still they hold that aesthetic value to it, right? And whether it is ethical to extract them or not is again a very important question, but certainly they are very beautiful and they attract our attention. Right? So these are the provisioning services that are there in nature. As you can see here, these are the regulating. They regulate how carbon is stored, how they water cycle, and everything else is the regulatory services. There is carbon sequestration. I think I've explained it to you. That's what the plant does. They take in the CO2 and they release oxygen to it, right? So when they do so, they store it in plant as in soil. They regulate climate. For easy understanding, we can also say that they regulate weather. We know in a broader perspective that it's winter season going on right now, and then there will be summer. Why summer come, and also why it rains at certain time, right? What kind of pressures are created across the globe, because of which you know that in this particular time, because the radiations are coming at certain angle, certain amount of air would be heated up, it will go up, and to fill that space, the air would come over the ocean and they will bring in lots of humidity with it, and they will precipitate at this particular point in time. So all this climate regulation is also done by our ecosystem. And when you know that this is the time when it is going to rain, you sow your seed accordingly. So you can see how they are interrelated. So if the rain is not happening at the time you have predicted it, or it had been happening for many years, right? Then you could see what kind of loss we are talking about. Because you know that the rain comes on X week, therefore X minus certain week, you have sowed the seed and you are waiting, you know that this is the time the seed must receive water for it to germinate. If it is delayed by a week, your yield drops, right? And you also know that the crop would be ready on Y time. That is the time for you to harvest and let it sun dry. What if for certain reason the rain happened at that point of time? The whole crop is wasted, right? So that is the kind of regulation, the climate regulation impact our lives, not just our life. I just told you how it impact our agriculture. Now, waste decomposition and its detoxification, how we waste in terms of all sorts of waste, but let's look at the bio waste. When a system dies, when an organism dies, how it decomposes and goes back to the atmosphere. And they have the detoxification impact as well, right? You need to study it a bit in detail, but I'm not going in detail of it, but they have the detoxification impact as well. Water purification, as I told you, when water flows, there are certain microbes in the water which cleans the water, right? Pest and disease control is also done by ecosystem. For example, certain kind of mosquitoes breed under certain temperature range. Now, because of the change in temperature that happened because of the spinning of the globe, those vectors die. So they can control that as well. Flood prevention and control is also done by ecosystem. Somebody talked about mangroves when we started our lecture, right? So they control, they control the flood, which otherwise would have come from had those mangroves not been there. So these kind of services are also derived, regulatory services are also derived from our ecosystem. Non-material benefit, recreational, as I told you, cultural, books, films, painting, all motivations are taken from our nature. Recreational activities, as I told you, and science and education, of course, schools are taking kids to those excursions where they go and see, right? So this is a service that they are giving, right? The best way to make someone understand something is to take them there. No matter how much I'm telling you about the ecosystem services, if I take you to a forest, and you see all those change happening with your own two eyes, and you experience it, be there in real time, in the real shape, the understanding that you would have would be different from what I'm teaching right now over the screen. Right? So that is again, that learning part of it is also derived from the ecosystem that we have. Right? No matter if the fruit that we are talking about is not grown in your region, you will not understand how hard I try to make you understand that this is how it tastes. You will not understand. The understanding is when you actually experience it yourself, right? So this is again a service. The experience is again a service that we are getting from our ecosystem. And the supporting services, of course, as you can see, this is the nutrient cycle. How it moves, a carnivore, a herbivore is there, it is eaten by a carnivore, a part of it goes into its body, the other part of it, whatever is the leftover, is taken by other scavengers, right? And they all do their job. They all do their job. And this is how, because see, if I put a boundary across the globe, the total amount of everything, the nutrient is fixed. The question here is, how these nutrients are moving from one sphere to the other sphere. This dynamic equilibrium is exactly the same thing. If you look at carbon, the total amount of carbon that is present, if I put a big boundary, including the earth and the atmosphere, is constant. The problem here is that we are extracting the carbon from the lithosphere, from the earth, and we are putting it into the atmosphere when we are burning it. That is the problem. The net amount of carbon remains same. The whole problem of climate change is because we are taking it out from the earth and we are putting it into the atmosphere. The net sum is constant. C atmosphere plus C earth is constant. The problem is the CA is now more than CE, which is earth, right? So this is, and the equilibrium which is there, there's a dynamic, there's a continuous flow. The net amount remain constant, but there's a continuous exchange which is happening. This is what is, and as you can see here, a dung beetle helped to turn animal waste into organic material that can be reused by primary producers. As you can see here, it is a very important job that this bug is doing. If it is not there, it's the dung beetle, right? These dung wouldn't have been decomposed. The service that this dung beetle is giving to us is also priceless. You need to put a value to it. Because of this, this organic material that I'm using in my field, had it not been there, I probably would have used a chemical fertilizer. And the chemical fertilizer that we're buying from the factories, we know the value for it, that it costs X amount for 1 kg. So at least can I put that value, the replacement, that is one. Secondary benefit could be that since I'm using all organic material and I'm not using anything which is synthetic, for example, my farm may end up getting an organic certification because the product that comes from organic farm are sold at a higher price. So that is a secondary or a derived benefit that I also have from this dung beetle. So you have to quantify, you have to first identify all the benefits, and then you have to add monetary value to all those benefits. That is what is the valuation of ecosystem services. Right, so now here is, I'm giving you this example to consider. It's a coastal wetland, and you look at the graphic below of the coastal wetland and see how many key features and ecosystem services you can identify. So this is, as you can see, that's a wetland. So there is the community. You see some trees, some grassland, some rock here. I see fishermen here, some fishes, ducks, some grasses. Wind is blowing, right? And somebody's enjoying rafting here, or So tell me what kind of, we have already seen it, right? Some providing, as you can see here. So there's provisioning benefit, there's regulatory benefit, there's cultural benefit, and then there's supporting benefits. Let's go by the methodology which is given by the Millennium Ecosystem Assessment Report. So based on this, what kind of services you see here in this picture? So take 2 minutes and identify them. What are the various services that you see? And I'm giving you 2 minutes for it. look at it. If you have any query, you can unmute and ask. So yes, let's get back to this hands-on. So I'm sure you have identified some of them, but let's go and see what all are there. So if you look at, this is how it is. What you see here is a coastal community which is protected from storm surge by this wetland, right? Because of this wetland, as I told you, the surge that happened is protecting, right? This wetland is protecting them from the surge which is happening in the ocean. It also, because of the storm, the wind that is coming is also kind of broken down. The speed of the wind is broken down. What you also see here, this is another service that this wetland is providing to this community. And there is also agriculture which is happening, because of which because the wetlands are low-lying. So the irrigation that you are doing, because of which there is a nutrient runoff from the soil to this wetland, the nutrient runoff from agriculture. This nursery area, you have a nursery here, an area as you can see here, right? And there are recreational fishing also that people are doing. Wildlife and wetland ecosystem increases recreational and tourism values. So when you put value to it and you see that people could come and do tourism here, but then it has to be in a very, it has to be controlled tourism. You cannot bring in lots of people coming together for fishing and they just take away all the fish. No. So you have to see what is where you can have the equilibrium maintained. So that is happening. There are salt marsh, there are oyster reef, as you can see here, and then there are sea grasses. These are the various identities that we can see here in the ecosystem, and some of them are giving services to this community, right? There are habitat and biodiversity, there are recreation, nutrient regulation, soil and sediment regulation, disturbance and hazard, natural hazard vegetation. Because of that wetland, it protected, right? Cultural values, there is water supply, and then there is food production. These are some of the major services that we derive from wetlands. So if we have wetland, these are the things, not all of them, but major categories are this. And if you go back to the previous slide, you could see that of these 1, 2, 3, 4, 5, 6, 7 services that we have identified, it is certainly providing 5 or 6 of them, right? So this is, and the question is, can I remove this wetland and come up with some activity, human-induced activity? So I'll be losing on all these services that the wetland is providing to the community at the moment. Therefore, valuation of ecosystem services is very important. Now, if you look at seed, just to give you an example that how services are, how important the services are. The seed pods, that we see, it's a static system. You put it in a, as long as it is packed, it's a static system. Nothing is happening. It will remain as seed. There's a natural decay that happens, but it's there. It's static. It is not interacting with anyone, right? But the moment you take that seed and you put it in soil, the system becomes dynamic. It starts to interact with its surrounding, with the soil. Otherwise, the same seed when it is packed in a carry bag or a polythene bag, nothing is happening. It is lying like that. It's static. Nothing is happening. But the same seed, I take it out from that bag and I put it in soil. I just change the atmosphere. I just change the surrounding, right? Now it becomes a dynamic system. It starts to interact with its surrounding. It takes moisture, it takes sunlight, it takes nutrient and other things. And it is now start to germinate. Within interaction, that change over time. So it becomes dynamic the moment you bring it to some other system. Now let's quickly look at the valuation of ecosystem services video just to give you a broader understanding of the whole thing. Right.
If a good or service is provided by nature, we'll call them ecosystem services. So we would say in this series, we're trying to quantify the value of ecosystem services. Okay, let's look at forests and classify the kinds of ecosystem services they offer. We could do this for any sort of ecosystem, but we're just going to look at forests to narrow our study. There are different ways of organizing and classifying the benefits. Under the system we're looking at, there are 5 classes of ecosystem services. First, there are direct benefits. Okay, it's when we get utility from using a substance directly, or when our willingness to pay for a thing comes from our value of that thing. So from a forest, harvesting the wood would be a direct benefit. Taking water would give a direct benefit. Getting animals from hunting or trapping would be direct benefits. Basically, taking and using any substance from the forest would give a direct benefit. Okay, it's utility from using the thing directly. But walking on a hiking trail would also be a direct benefit. It doesn't have to use it up. It can be non-consumptive as long as it's still using it directly. The utility or benefit comes from direct interaction with that substance. So any recreational uses like hiking or fishing or camping or swimming or enjoying scenic views would be direct benefits. Similar to value from direct uses is value from indirect uses. For something we call a direct use, we are willing to pay for it because of the utility that thing gives us. With an indirect use, for example, some aspect like a wetland that improves water quality, or the way the soil under a forest will allow infiltration, increasing the amount of water available, these ecosystem services are giving us utility indirectly through the other thing that we're using. So our willingness to pay for them really all depends on our use of this other thing. Another example, if none of our crops required pollination, we would not value bees nearly as much as we do right now, even though the bees haven't changed. So for example, with a forest, a mangrove on the coast will help lessen the damage from storms, taking some of the impact from wind and water. This allows a lot of human productions to continue and save a lot of money in damages. Forests can help prevent erosion, mangroves helping prevent coastal erosion, keeping the land from falling into the sea. Preventing soil erosion protects water sources from pollutants, protecting fish habitats, among other things. The water retention of the soil helps prevent flooding and helps keep water in place, lessening the harm from droughts when the rain stops and keeps rivers flowing. Trees can help reduce the temperature of a microclimate by constantly transferring the energy from the sun into water that evaporates away. Also, it makes shade. And right beside that, carbon is sequestered in the soil and the trees, which can help reduce the greenhouse effect. Forests can house natural pollinators that offer a vital service to farmers. And lastly, pharmaceutical companies often start with natural chemicals as the base from which to build more powerful drugs, like aspirin and morphine. And farmers and genetic engineers will do a similar thing. So a diversity of plants and animals could represent an input into productions like these. And otherwise, there are a bunch of ecosystem services that seem to correlate with biodiversity that you can look up. With indirect environmental services, we don't always know the effects a creature will have. For example, in India, many people do not eat cows because they are considered sacred, but there's a lot of cows around. It's the vultures and other animals that eat the cows. In the 90s, the population of vultures dropped from millions to thousands. This ended up being attributed to an anti-inflammatory drug that was used to treat some livestock that just happened to be fatal to vultures. The uneaten carcasses were left to pollute some water supplies, and also the vultures' corner of the scavenging niche was filled by dogs and rats and other animals, whose population flourished. But while the vulture's gut will kill any pathogens, the dogs' and rats' guts don't, and will become carriers for diseases from the corpse, or just other diseases. Dogs will bite a human, but vultures won't. The vultures were essentially offering a sanitary carcass disposal service. The point is, there are a lot of involved interactions between us and the world around us. With indirect benefits especially, we don't typically appreciate or even know about these things until they're gone. So direct uses and indirect uses are use values, where the ecosystem is doing something for us physically, and our willingness to pay for them reflects that. But there are also non-use values, where people's willingness to pay comes from less tangible aspects of the ecosystem. First up, bequest values. Which would you rather your children or the next generation inheriting, a wetland or a parking lot? The bequest value isn't about which one offers the greater net present value, it's about which feels better to pass on. It's a non-use value. So in terms of forests, a local community, or maybe an Aboriginal community especially, may place a high cultural value on the life that they have formed around the use of a forest. This is their entire culture and they want future generations to be able to continue this. The bequest value can come from passing on any aspect of the forest, depending on what the community values, hunting or logging or whatever. Existence value is another non-use value. Existence value is the utility gained in the satisfaction in knowing something exists, like whales or the Grand Canyon or whatever. In terms of forests, the continued existence of, for example, the Amazon rainforest and the diversity of species it houses gives people value beyond any physical services they provide, although it can be any local forest or species too. It's an intangible thing, but at the same time it does fuel real money transactions. For example, people giving money to charities that promise to save the whales or the rainforest or whatever. They're not giving as an investment for future vacations they may take. It's a willingness to pay to live in a world where the rainforest exists. Lastly, somewhere slightly between the world of use and non-use values, there are option values. Option values exist in some markets. For example, let's say you're offered this house at a specific price. You may not know if you want it or not for whatever reason, but it's a limited time offer. So you enter into an agreement with the owner that gives you the right to buy it in, say, 3 months if you want. They're not going to sell it to anyone else, but you're going to have to pay for the privilege. Whether or not you actually end up buying the house, you are willing to pay for this option. It's the value in having the option of using something in the future. In terms of a forest, this could be the option to use the forest for hiking or hunting or fishing, or even the option to use it for timber. Basically, any value can be valued for the option of having it. So a number of people will have a willingness to pay to keep something around in case they choose to use it in the future, especially if the change that's coming is going to be permanent. In theory, all these values added up together makes the total economic value, and we can use that to compare that to whatever the competition is. But some of these will be kind of controversial, particularly the non-use values. And it's a lot of work to try to find the total economic value before and after whatever change, especially with a seemingly endless stream of indirect benefits. So instead, we have to look at the most important aspects to decision makers and try to only focus on the things that are going to change. In the next video, we'll look at how to pick the ecosystem service to focus your study on.
Right. So that was very briefly in terms of yes, so that was very briefly on how ecosystem services are categorized. One, as I told you, that was as per the Millennium assessment report. The other one was the direct and indirect use, how you derive it, so on and so forth. But the easiest way to do is the box in the arrow model, right? And it requires no very deep understanding. But let's start with this. Now, if you look at anything, let's start with an egg. We have all seen that, right? And if we take that as our ecosystem, as a representative of our ecosystem, so it is in its equilibrium, it is doing its job, it's not very visible to us, and then we bring in some kind of an action, some kind of a force, something. For example, if it's an egg and the force that we are providing here is heat, if we really heat it up a lot, what will happen? It will turn into a hard-boiled egg. This is one kind of force. The other kind of force is excessive force, where you can either drop it, throw it, or smash the egg. As a result, the egg will break. As you can see here, we are bringing in some kind of change in the atmosphere. Otherwise, the egg was lying quietly on your table, yeah, or on a pan, right? As long as you didn't provide heat to it, it was in its original state, right? But when you brought in some changes, and each change that we are planning in can bring in a different kind of change in our ecosystem. As I told you, when you heated it up, it became a hard-boiled egg. When you just threw it or dropped it, it just got broken, right? So what we can do, we can think of an ecosystem, and through this, we call it the box and the arrow method, you could speculate what possible things could be done. This is an ecosystem. If I do this, it will clean the water. If I do this, it will destroy the water body, or it's completely gone, so on and so forth, right? So you draw the bow and arrow method, you identify, you quantify. Maybe in the first time when you are doing it, you end up doing a very primitive job, but at least the job is done. So let's start with that. So you start with that, and then you move on to categorize it as per the MEA report, where you have the provisional services, the regulatory services, the supporting services, the cultural services, and you could make it as complex. When you make it more complex, you make it more real. That's the thing, right? But at least to begin with, if we have not done it so far, then let's start with this, the box and arrow model, where you identify it and you see what could be done, and then you add some value to it as per your judgment. And if there are some guideline as per that guideline, so what are the values of it? So when it's a hard-boiled egg versus simple egg or a broken egg, there is no value whatsoever. Here, maybe you have ended up adding more value to the system. That could be done as well, right? Ecotourism for that matter. So whatever service that ecosystem was given to the community was there. And when you bring in tourism, a controlled tourism, I'm still using the word controlled tourism, you're not damaging the ecosystem, but you have brought in an activity because of which there is an economic impetus, right? The people living in the community could benefit because of there are people who are coming in and they are doing those recreational activity. They would need some place to stay and to have their meals. So there is a business opportunity there. So the community benefit in totality. But as I told you, you have to see what is the resilience of the ecosystem. What is it that it can take? Now, what does resilience mean? That is important. Whenever we try to bring a change, it's a very scientific terminology. Whenever you try to bring in a change in a system, the system initially tried to resist it. But after a point, it cannot resist. It just breaks down and changes, right? So as long as we are practicing ecosystem within the resilience of the ecosystem, it's a wonderful activity. Even with ecotourism, if you're over exploiting it, it should not be categorized as ecotourism. That's my opinion. Okay. So let's understand the resilience of the ecosystem. So what does resilience means? The capability or degree to which an ecosystem can resist perturbation and remain within the functional boundary, retain its identity that characterize it without flipping to a different set of functional bodies. You know, if you start boiling egg, I gave you the example of egg in the previous slide. It's not that it will change into a hard-boiled egg the moment you put it in water, right? Or to that matter, even a thaw water, right, which is just feel warm. You know, it start changing its form. You know, it start to become hard-boiled egg or coagulate. It's all protein inside it. It start to coagulate only when it is subjected to a certain temperature, and that certain temperature is 100°F, which is about 40°C. It's only when the water is more than 40°C that it will start to change. Before that, even if you put it in water, but the water temperature is less than 30 degrees or 35 degrees, nothing will happen to that egg. You keep it in that water for as many hours as you want. So that resistance, but the moment temperature goes beyond 40, it changes its characteristic. You drop the egg, you know, you spin it slowly, or you drop it very slowly, it happens, it doesn't break. But only when you drop it at a certain force, it cracks open. So that resistance is the resilience of your ecosystem. So we try to any change that we are bringing in, primarily from ecotourism point of view, as long as it is within the resilience limit of the ecosystem, it's a good activity. It's a good change that you are inducing into the system. Okay, right? And the amount of change a system can undergo and remain in the same region, retaining the same structure, function, and feedback. That is the resilience of the system. And the best way, as I told you, when it comes to ecosystem, the best way we can envisage is to look at from the other or the opposite point of view, right? So the opposite of resilience is vulnerability, how vulnerable your ecosystem is. Some ecosystems are very vulnerable. So in those ecosystems, bringing in any kind of change is strongly not recommended. There are certain systems who are very vulnerable. Some hotspots, some biodiversity hotspots are very vulnerable. So if you keep on bringing any kind of a change, the biodiversity will be lost permanently because they are, they are holding some very precious species or things like that. So those valuation we have to see. All this development work that are happening, be it in terms of power plants, dam, road infrastructure, transport, taking a road or a railway track inside a forest, what kind of changes we are inducing, what kind of an impact it may have. All those things need to be studied, right? So that is the resilience and vulnerability part of the ecosystem services. Now, I think we are done for the day. If you have any query, I'll take it. Or else I'll stop sharing. If you have something to say or ask, you can do it at the moment. You can also talk to me. I'll play a video, which is in the break. You can go for your break, but if you're not going anywhere, maybe you could listen to it. Only for that sake, I'm running it. Otherwise, this session is over. I will be there. If you have any query, you can ask me.
Hello.
Yes.
Thank you for your nice presentation, and it is very important for us to control our systems. Actually, what I wanted to ask you is that it is must to disturb the ecosystems to live. For example, having this large dam, mining of coal and other petroleum, or some necessary things for us for living. So, what is recommended to have better ecosystem? It is must to disturb, but what we can do for controlling this all?
The important thing is you have to see how resilient your ecosystem is. See, I'm not saying that don't construct a dam or don't go for mining, right? But if you have an option, and it is also a fact that whenever we go for mining, whenever we go for damming to create a dam, we are tampering with the nature, that's for sure, right? But here what you can do is the elimination of choices, maybe. So one of them, which is on a scale of 0 to 8, 0 to 10, is the vulnerability index is 8, let's say. If I'm saying that the vulnerability index is 8, right? And then there are other options where the vulnerability index is 5. And you have to go for a hydropower plant. You need this much amount of energy because it will bring in economic benefit to the people, to the community. You have to do it. Or for the basic necessity, because you want to electrify a community, you have to produce electricity. And the easiest way is to go for a hydropower because you have plenty of water, whatever reason. You've identified that, okay, fine. One agency has given you a report that water, hydro-based electricity is the solution. Now, the next thing is, where do I put the dam? Which site should I select? Now, I'm very sure that there are a couple of options that are available with you. One is A, the other site is site B, and then there is site C. Now, between site A, site B, and site C, you do the analysis, which of the ecosystem is resilient, which of the ecosystem is very vulnerable. Then we don't go for the vulnerable one. You also see who all are affected, what kind of services that they are giving would be stopped if I come up with a dam on those areas. So it is, I think, more or less with the elimination of choices rather than going with my top choice. So this is out of question because it is a very vulnerable ecosystem that we are looking at. And if we do that, for example, there are certain, let's say if you bring in a change because of which bees are gone. Now, if the bees are gone, it not only impacts the bee, but your agriculture also. So the question now onto you is whether you want to bring in electricity at the cost of agriculture or not, right? So therefore, you have to look at what kind of services you would be deprived of if you come up with a dam in that place. And then you weight it and you identify the one which is less damaging. All of them are damaging to nature. Of course, whenever we come up with any kind of an artificial activity, we are tampering with nature. But then, therefore, this valuation of ecosystem services is very important. You evaluate it and evaluate it very in a very detailed way, and then you see that for site A, site B, and site C, where is it that I am doing least damage, and then you go for it. Sometimes what happens when you identify the one which is least damaging, probably the cost of construction there is a bit higher because the valleys in certain nature, things like that, and we fall prey to it because it's cheaper, and at the end of the day the cost of electricity will be cheaper, right? But then I think, in my personal opinion, you should go for the one where the loss of ecosystem services is least. Maybe it will end up in higher cost of construction of the dam, and we end up not choosing it because of practical reasons. But ideally you should go for, or you find a midway somewhere between the one which is least damaging versus the one which is most damaging, and there's a conflict, right? And you have to use your own judgment skill basically here at this point in time.
Thank you. Thank you.
Thank you. So I'll just show you a TED talk. I found it very interesting, so I thought that I'll just do it. I'll leave it for you to watch it during the break time. Sound.
I'm here to talk to you about the economic invisibility of nature. The bad news is that Mother Nature's back office isn't quite working yet, so those invoices don't get issued. But we need to do something about this problem. I began my life as a markets professional and continued to take an interest. But most of my recent effort has been looking at the value of what comes to human beings from nature, and which doesn't get priced by markets. A project called TEEB was started in 2007, and it was launched by a group of environment ministers of the G8+5. And their basic inspiration was a Stern review of Lord Stern. They asked themselves the question, if economics could make such a convincing case for early action on climate change, well, why can't the same be done for conservation? Why can't an equivalent case be made for nature? And the answer is, yeah, it can. National, local community. And doing for nature what Lord Stern and his team did for climate is not that easy. And yet we began. We began the project with an interim report which quickly pulled together a lot of information that had been collected on the subject by many, many researchers. And amongst our compiled results was the startling revelation that in fact we were losing natural capital, the benefits that flow from nature to us. We were losing it at an extraordinary rate. In fact, of the order of $2 to $4 trillion worth of natural capital. This came out in 2008, which was of course around the time that the banking crisis had shown that we had lost financial capital of the order of $2.5 trillion. So this was comparable in size to that kind of loss. We then have gone on since to present for international community, for governments, for local governments, and for businesses, and for people, for you and me, a whole slew of reports which were presented at the UN last year, which address the economic invisibility of nature and describe what can be done to solve it. What is this about? A picture that you're familiar with, the Amazon rainforest. It's a massive store of carbon, it's an amazing store of biodiversity, but what people don't really know is it's a rain factory. Because the northeastern trade winds, as they go over the Amazonas, effectively gather the water vapor. Something like 20 billion tons per day of water vapor is sucked up by the northeastern trade winds and eventually precipitates in the form of rain across the La Plata basin. This rainfall cycle, this rainfall factory, effectively feeds an agricultural economy of the order of $240 billion worth in Latin America. But the question arises, okay, so how much do Uruguay, Paraguay, Argentina, and indeed the state of Mato Grosso in Brazil pay for that vital input to that economy to the state of Amazonas, which produces that rainfall? And the answer is zilch, exactly zero. That's the economic invisibility of nature. That can't keep going on because economic incentives and disincentives are very powerful. Economics has become the currency of policy. And unless we address this invisibility, we are going to get the results that we are seeing, which is a gradual degradation and loss of this valuable natural asset. It's not just about the Amazonas or indeed about rainforests. No matter what level you look at, whether it's at the ecosystem level or at the species level or at the genetic level, we see the same problem again and again. So rainfall cycle and water regulation by rainforests at an ecosystem level. At the species level, it's been estimated that insect-based pollination, bees pollinating fruit and so on, is something like $190 billion worth. That's something like 8% of the total agricultural output globally. Completely passes below the radar screen. When did a bee actually ever give you an invoice? Or for that matter, if you look at the genetic level, 60% of medicines were prospected, were found first as molecules in a rainforest or a reef. Once again, most of that doesn't get paid. And that brings me to another aspect of this, which is to whom should this get paid? That genetic material probably belonged, if it could belong to anyone, to a local community of poor people who parted with the knowledge that helped the researchers to find the molecule which then became the medicine. They were the ones that didn't get paid. And if you look at the species level, you saw about fish. Today, the depletion of ocean fisheries is so significant that effectively it is affecting the ability of the poor, the artisanal fisher folk, and those who fish for their own livelihoods, to feed their families. Something like 1 billion people depend on fish, the quantity of fish in the oceans. 1 billion people depend on fish for their main source for animal protein. And at this rate at which we are losing fish, it is a human problem of enormous dimensions, a health problem of a kind that we haven't seen before. And finally, at the ecosystem level, whether it's flood prevention or drought control provided by the forests, or whether it is the ability of poor farmers to go out and gather leaf litter for their cattle and goats, or whether it's the ability of their wives to go in and collect fuel wood from the forest, it is actually the poor who depend most on these ecosystem services. We did estimates in our study that for countries like Brazil, India, and Indonesia, even though ecosystem services, these benefits that flow from nature to humanity for free, they're not very big in percentage terms of GDP, 2, 4, 8, 10, 15%. But in these countries, if we measure how much they're worth to the poor, the answers are more like 45%, 75%, 90%. That's the difference, because these are important benefits for the poor, and you can't really have a proper model for development if at the same time you're destroying or allowing the degradation of the very asset, the most important asset, which is your development asset, that is ecological infrastructure. How bad can things get? Well, here's a picture of something called the mean species abundance. It's basically a measure of how many tigers, toads, ticks, or whatever, on average, of biomass of various species around. The green represents the percentage. If it's dark green, it's like 80 to 100%. If it's yellow, it's 40 to 60%. And these are percentages versus the original state, so to speak, the pre-industrial era, 1750. Now I'm going to show you how business as usual will affect this. And just watch the change in colors in India, China, Europe, Sub-Saharan Africa, as we move on and consume global biomass at a rate which is actually not going to be able to sustain us. See that again. The only places that remain green, and that's not good news, is in fact places like the Gobi Desert, like the tundra, and like Sahara. But that doesn't help because there were very few species and volume of biomass there in the first place. This is the challenge. The reason this is happening boils down, in my mind, to one basic problem, which is our inability to perceive the difference between public benefits and private profits. We tend to constantly ignore public wealth simply because it is in the commonwealth, it's common goods. And here's an example from Thailand, where we found that because the value of a mangrove is not that much, it's about $600 over the life of 9 years that this has been measured, compared to its value as a shrimp farm, which is more like $9,600, there has been a gradual trend to deplete the mangroves and convert them to shrimp farms. But of course, if you look at what exactly those profits are, almost 8,000 of those dollars are in fact subsidies. So you compare the two sides of the coin and you find that it's more like 1,200 versus 600. That's not that hot. But on the other hand, if you start measuring how much would it actually cost to restore the land of the shrimp farm back to productive use, once salt deposition and chemical deposition has actually had its effects, that answer is more like $12,000 of cost. And if you see the benefits of the mangrove in terms of the storm protection and cyclone protection that you get, and in terms of the fisheries, the fish nurseries that provide fish for the poor, that answer is more like $11,000. So now look at the different lens. If you look at the lens of public wealth as against the lens of private profits, you get a completely different answer, which is clearly conservation makes more sense and not destruction. So is this just a story from South Thailand? Sorry. This is a global story. And here's what the same calculation looks like, which was done recently, well, I say recently over the last 10 years, by a group called TrueCost. And they calculated for the top 3,000 corporations, what are the externalities? In other words, what are the costs of doing business as usual? This is not illegal stuff. This is basically business as usual, which causes climate changing emissions, which have an economic cost. It causes pollutants being issued, which have an economic cost, health costs, and so on. Use of fresh water. If you drill water to make coke near a village farm, that's not illegal, but yes, it costs the community. Can we stop this, and how? I think the first point to make is that we need to recognize natural capital. Basically, the stuff of life is natural capital, and we need to recognize that and build that into our systems. When we measure GDP as a measure of economic performance at the national level, we don't include our biggest asset at the country level. When we measure corporate performances, we don't include our impacts on nature and on what our business costs society. That has to stop. In fact, this was what really inspired my interest in this space. I began a project way back called the Green Accounting Project. That was in early 2000, when India was going gung-ho about GDP growth as the means forward, looking at China with its stellar growths of 8, 9, 10%, and wondering why can't we do the same? And a few friends of mine and I decided this doesn't make sense. This is going to create more costs to society and more losses. So we decided to do a massive set of calculations and started producing green accounts for India and its states. That's how my interest began and went to the TEEB project. Calculating this at the national level is one thing, and it has begun, and the World Bank has acknowledged this, and they've started a project called WAVES, Wealth Accounting and Valuation of Ecosystem Services. But calculating this at the next level, that means at the business sector level, is important. And actually, we've done this with the TEEB project. We've done this for a very difficult case, which was for deforestation in China. This is important because in China, in 1997, the Yellow River actually went dry for 9 months, causing severe loss of agricultural output and pain and loss to society. Just a year later, the Yangtze flooded, causing something like 5,500 deaths. So clearly, there was a problem with deforestation. It was associated largely with the construction industry, and the Chinese government responded sensibly and placed a ban on felling. A retrospective on 40 years shows that if we had accounted for these costs, the costs of loss of topsoil, the cost of loss of waterways, the lost productivity, the loss to local communities as a result of all these factors, desertification and so on, those costs are almost twice as much as the market price of timber. So in fact, the price of timber in the Beijing marketplace ought to have been 3 times what it was, had it reflected the true pain and the costs to the society within China. Of course, after the event, one can be wise. The way to do this is to do it on a company basis, to take leadership forward, and to do it for as many important sectors which have a cost, and to disclose these answers. Someone once asked me, who is better or worse? Is it Unilever or is it P&G when it comes to their impact on rainforests in Indonesia? And I couldn't answer because neither of these companies, good though they are and professional though they are, do not calculate or disclose their externalities. But if we look at companies like Puma, Jochen Seitz, their CEO and chairman, once challenged me at a function saying that he's going to implement my project before I finish it. Well, I think we kind of did it at the same time, but he's done it. He's basically worked out the cost to Puma. Puma has $2.7 billion of turnover, $300 million of profits, $200 million after tax, $94 million of externalities, cost to business. Now, that's not a happy situation for them, but they have the confidence and the courage to come forward and say, here's what we are measuring. We are measuring it because we know that you cannot manage what you do not measure. That's an example, I think, for us to look at and for us to draw comfort from. If more companies did this, and if more sectors engaged this as sectors, you could have analysts, business analysts, and you could have people like us and consumers and NGOs actually look and compare the social performance of companies. Today, we can't yet do that, but I think the path is laid out. This can be done, and I'm delighted that the Institute of Chartered Accountants in the UK has already set up a coalition to do this, an international coalition. The other favorite, if you like, solution for me is the creation of green carbon markets. And by the way, these are my favorites: externalities calculation and green carbon markets. TEEB has more than a dozen separate groups of solutions, including protected area valuation and payments for ecosystem services and eco-certification, and you name it, but these are the favorites. What's green carbon? Today, what we have is basically a brown carbon marketplace. It's about energy emissions. The European Union ETS is the main marketplace. It's not doing too well. We've overissued, a bit like inflation. You overissue currency, you get what you see, declining prices. But that's all about energy and industry. But what we are missing out is also some other emissions like black carbon, that is soot. What we are also missing is blue carbon, which, by the way, is the largest store of carbon, more than 55%. Thankfully, the flux, in other words, the flow of emissions from the ocean to the atmosphere and vice versa, is more or less balanced. In fact, what's being absorbed is something like 25% of our emissions, which then leads to acidification or lower alkalinity in oceans. More of that in a minute. And finally, there's deforestation, and there's emission of methane from agriculture. Green carbon, which is the deforestation and agricultural emissions, and blue carbon together comprise 25% of our emissions. We have the means already in our hands through a structure, through a mechanism called REDD+, a scheme for the reduced emissions from deforestation and forest degradation. And already, Norway has contributed $1 billion each towards Indonesia and Brazil to implement this REDD+ scheme. So we actually have some movement forward, but the thing is to do a lot more of that. Will this solve the problem? Will economics solve everything? Well, I'm afraid not. There is an area that is the oceans, coral reefs. As you can see, they cut across the entire globe, all the way from Micronesia, across Indonesia, Malaysia, India, Madagascar, and to the west of the Caribbean. These red dots, these red areas, basically provide the food and livelihood for more than 500 million people. So that's almost an eighth of society. And the sad thing is that as these coral reefs are lost, and scientists tell us that any level of carbon dioxide in the atmosphere above 350 parts per million is too dangerous for the survival of these reefs. We are not only risking the extinction of the entire coral species, the warm water corals, we're not only risking a fourth of all fish species which are in the oceans, but we are risking the very lives and livelihoods of more than 500 million people who live in the developing world in poor countries. So in selecting targets of 450 parts per million and selecting 2 degrees at the climate negotiations, what we have done is we've made an ethical choice. We've actually kind of made an ethical choice in society to not have coral reefs. Well, what I will say to you in parting is that we may have done that. Let's think about it and what it means. But please, let's not do more of that, because Mother Nature only has that much in ecological infrastructure and that much natural capital. I don't think we can afford too much of such ethical choices. Thank you.